let's talk about how to graph the following example here. So we're looking at graphing a quadratic equation, which is going to be, taking a look at this example, a negative parabola type shape. So when it comes to graphing quadratics, especially when they're given to us in this form here, this is called vertex form. And we do like vertex form of a quadratic equation because just by taking a look at our graph, there is a few key components that we can figure out and know just based off the actual equation. First off, right over here, I guess, so let me match this up with the vertex form of a quadratic equation, which looks like this right here. A lets you know if A is positive, we're talking about a positive parabola. If this number here in front is negative, then we know our graph is turning downwards like ours is going to be. Also, this HK right over here, which lines up with these two digits here, keep in mind that HK represents the vertex of your equation here. So the number on the inside of the parentheses, you always want to take the opposite sign of what that is. Ours says a positive 3, so for us we're going to use a negative 3. Always pull the number, grab the opposite sign of what it says. K on the outside though, K is always going to be normal. For H, again, drop down that number, change the sign. K, just drop that number right down. So our vertex, our HK, based off our equation, is a negative 3, 5. So just by taking a look at those two quick things from this graph, I know my graph is negative, which means it's going to be going downwards. I also know the vertex of my graph is a negative 3, 5. And if I plot that real quickly here, I know a negative 3, 5 is over here, and I know my graph is negative and it's going to be going downwards. So just by those two things, I have a very good idea of what my graph is going to look like here. Sometimes that's good enough. If they're just asking for a quick sketch, this a lot of times tends to be good enough for that. But if we want a little bit more information, I always find it's easier to go ahead and just start plugging in values after this point here. Typically when it comes to graphing a quadratic equation, we really just need 2 points. We need to know the vertex and just one other point. One important thing to note about a parabola anytime we're graphing it here, the first point that we always want to find out is the vertex, which we just did. Also, quadratic equations are symmetrical. If you pretend that there's an imaginary line right down the vertex here, if we were to fold this graph on that imaginary line, everything on the left matches up with everything on the right. If you fold it, it all should line up perfectly in sync with each other. What that lets us know, if we know that a given point is over here on this left-hand side, if we go the same amount, like let's say this point is 3 to the left, down 2, well, we can go 3 to the right, down 2, and plot the next point over here. They should always be the same distance outward and then the same distance down on either side. And that's always going to be true for quadratic equations. Go out, down the same amount, and then the next 2 points should match up with each other, the next 2, and so on like that. So after we find the vertex, we really just need to find at least one other point. So let's make life easier on us, and let's go ahead and just find the value of the point right next to it. And what I mean by that, this is the point negative 3, 5. So maybe let me pick a small number over here. Let me figure out what the graph is doing at negative 2. So what I'm going to do is I'm going to go ahead and just plug in negative 2 into my graph and figure out what that point is so that I can go ahead and mirror it on the other side. So we're just going to plug in a negative 2 into x into our equation, simplify this, and it'll give me my second and my third point. So when we simplify this, always work with your exponent first. Negative 2 plus 3 is just a 1. And when we square 1, 1 squared is just a 1, which means we're left with negative 4 times 1 plus 5, which is just a negative 4 plus 5, which is a 1. All right, so that tells us here when x is negative 2, our y is a 1. So if we take a look at that in reference from our vertex, it looks like we would go out 1 and down 1, 2, 3, 4. Out 1, down 4. Do the same thing on the other side. Out 1, down 4. That point would line up perfectly right over there. Again, out 1, down 4 on either side of your vertex, the same motion. Which means we now know the second and third point. We can now connect those dots, and that's all we need in order to graph that quadratic equation.